Hi, and welcome back again. So, on the last video, we are seeing how to calculate the inverse of transformation matrices, and we learn how to solve the equations that describe the motion of a robot. And what I said is, on this video, we will solve a 3 by 3 matrix, how to calculate the inverse of a 3 by 3 matrix. So this is what we're going to do right now. Um, and this is from the Appendix A. Uh, the book guides us to this appendix so we can revise how to calculate a 3 by 3, the inverse of a 3 by 3 matrix. And after this revision, we need to calculate the inverse matrix of a rotation matrix. So on this video, we will calculate um, the inverse matrix of a matrix with order of order 3. And after this video, I'm gonna release another one in which I will calculate the inverse matrix of a rotation matrix. So let's jump in. So we are on the Appendix A, and it brings a example, and before the the example, which is the example A.2, we got a example A.1, which is how to calculate the determinant of a matrix. And I already passed to you, remember that I said it's going to be useful, the algorithm. So we're going to use this algorithm, but I will change just a little bit the notations of the terms. So let me copy this, and I will change the notation so we can get as the same on the book. And let me do this on the order that the book brings to us. The example A.1, is how to calculate the determinant of a matrix 3 by 3, a matrix of order 3, a quadratic matrix of order 3. And right now, I will just change the notation of the terms. Right here, I'm using A1, A2, A3, but right now, I will change this by A, B, C, D, E, F, G, H, and I. And the determinant of this matrix, um, it's the same as this one, but right now I will just change the order, the notation of the terms. Okay, and it brings two methods to calculate the inverse of a matrix. And on the video about how to calculate inverse of a matrix, I present how to calculate the inverse of a matrix of order 2, a matrix 2 by 2. And for a matrix 3 by 3, it's different. We need to find the adjoint matrix. We need to find the matrix of the cofactors. It's more labor to solve. I said adjoint matrix, right? Okay. So on this video, we will just to use the method 1, which is enough for our purpose. And I think I don't said find the minors. So we need to find the minors, we need to find the matrix of the cofactors, and we need to find the adjoint matrix. So let me write this. When calculating for a 3 by 3 matrix in larger we need to find the minors, we need to find the matrix of the cofactors, and we need to find the adjoint matrix. And we will do all this step by step. And there is no better way to learn something than solving the example. So the example 2 A.2 that the book bring to us ask to us to calculate the inverse of the following matrix. So is the matrix A with the terms 1, 0, 1, 0, 1, 4, 5, -2, and -1. And I will already copy this to use as reference. Let me copy the whole thing. Okay. So this term is A, right here B, C, O, D. Right here's D. Sorry. B E F G H I. So the first step is to calculate the determinant of this matrix. So the determinant of this matrix A, we have already this algorithm. Let's use it. Okay, so it's going to be A, which is equal 1 times A times I minus 1 minus F times H. F times H. Minus B, which is equal 0. So we can already eliminate this whole term of this determinant plus C, which is equal 1 times D times H, and D is 0. So we are left with E times G. E is equal 1 times G, which is equal 5. So the determinant of this matrix 1 minus 1 plus H plus 5. Right here is minus G minus E times G. So right here is minus 5. I have to correct this, and the determinant is equal to right here, sorry, is minus E times G. Okay. And the second step is to transpose the matrix. So we have to swap the lines by the columns. So you have just to take this original and swap the lines by the columns. In doing this, we are left with this following matrix, transposed matrix of A. Okay. And the third step is to obtain the adjoint matrix. And this is laborious procedure, so I will do with you step by step. So we have to take the original matrix and each term, each entry will generate a determinant. So what we have to do is to block out the line in the column of the entry, the the element that we are calculating, and calculate the determinant with of what is left. We are left with a 2 by 2 matrix, and the determinant of this entry, this term, this element, is going to be 1 times minus 1 minus 4 times minus 2, which is equal 7. And we have to repeat this procedure. We block out the column and the line of this entry, and we calculate the determinant of what is left. So the determinant is equal 4 times 5 minus, and right here is minus 5 times 4, which is equal minus 12. And we have to do this for all these terms of these entries or elements, what you prefer. Again, we block out the column and the line of the entry and calculate the determinant of what is left. Which is equal minus 5. Right here, we block out the line, we block out the column of this element of the matrix, and calculate the determinant of what is left. Minus 1 times minus 2, which is equal to and now right here, we block out the column, we block out the line of this entry, element, whatever, and calculate the determinant of what is left. Minus 5 times 1, is equal minus 6. And we have to repeat for all these elements. Pardon me, obviously is 2. Now for the last line, repeating the procedure, we block out the column, the line, and calculate the determinant of what is left. And the determinant one times 5 minus 1 times minus 1, 5, which is equal to 6. And finally, the last term, entry, element, whatever you want to call this. We block out the column, we block out the line, and calculate the determinant of what is left. Which is equal 1. So now we have our adjoint matrix. So we find the minors, and the minors compose the adjoint matrix. So the adjoint matrix is equal also, is the same as the transposite of the minors. Let's just represent by the adjoint. So it's 7, 12 minus 5, and I have to pass to you something that I didn't, that I'm missing, which is important. We have to switch the signs. When we are calculating the minors. So for the minors that compose this adjoint matrix, we have to switch the signs. And so we got 7 minus 12 minus 5. 7 minus 12 minus 5 2 minus 6 and minus 2. 2 minus 6 and minus 2. And 1, 6 and 1. One, 6 and 1. And the adjoint matrix will be 7, 12, minus 5. Um, okay. Minus 2, minus 6, 2, minus 1, 6, and 1. And we find the inverse when we divide by the determinant of the matrix. So remember that we do 1 over the determinant, which is equal 2, which is equal to so the determinant, the inverse of this matrix will be the adjacent of this matrix divided by the determinant of this matrix. So we copy this and divide by the determinant, and we will obtain the inverse. So is 7 divided by 2, which is equal 3.5. 12 divided by 2, which is equal to 10. 5 divided by 2, which is equal to 2.5, and so on and so forth. And we can do a proof. If we multiply this inverse by his original, we must obtain its identity. So let's do this. Let's do this proof. Let's take the original matrix A, and multiply by its inverse. And if we do this, we got the identity, and the identity is the main diagonal. Fill it out with ones, and the rest of the terms is zero or zero. And that's it, how you can calculate a, the inverse of a 3 by 3 matrix. So we do this so to revise, and now we can calculate the inverse matrix out of a rotation matrix, and we will do this on the next video. And for now is all. Thank you.